Hey guys, so now that you've watched the video on force fields, I want to go over the formulas between electric and gravitational. So electric force, we label that as Fe. We have K, Q1, Q2 divided by D squared. So I'm going to go ahead and label these what they mean, and then I'll go over the gravitational one as well. Fe stands for the electric force, and we measure that in newtons. Okay. K is Coulomb's constant. This whole law is Coulomb's law. I'll put that up here. Okay, it's known as Coulomb's law. So the K in the formula is actually Coulomb's constant. Okay, and that number is going to be, since it's a constant, I'll give it to you, it's 9 times 10 to the 9th. And the units you don't need to remember, but I'll go ahead and tell them to you. They are Newton meters squared over coulombs squared. So that number, 9 times 10 to the 9th, you'll always use for K in the formula. Then you have Q1. That's going to be the charge of the first particle. Charge of first particle. And then you're going to have Q2, charge of second particle. Both the Q's stand for charge, and charge is going to be measured in coulombs, and that's a capital C. Okay, like for force we use newtons, for charge we use coulombs. Okay, then moving forward, the bottom letter here is D squared. We square that in the formula, so I'm just going to write D, that's distance. And we measure that in meters. Okay, so that is Coulomb's law. So that's the electric force that we're going to be discussing in this unit. And then you also have the gravitational force that was discussed in that video. Let me erase this part so I can write the rest. Okay, so the gravitational formula is the force due to gravity, so that's Fg. That's another force, and we always measure forces in newtons. G is another constant, that's the gravitational constant, and that is going to be 6.67 times 10 to the negative 11th. That's the constant number you would use for that one. The M is the mass of object 1. That's measured in kilograms. M2, mass of object 2, also measured in kilograms. And then the D under here, same thing, distance. And that's measured in meters. Okay, so I'm going to show you one practice problem with Coulomb's law. So I'm going to go back to this one, and I'm going to show you this that will be on the blog later. Let me go ahead and erase this one. And put this paper here for you to see. Okay, so this is a Coulomb's law example problem. You can see the formula up here and everything that's the formula means. And then here is an example problem. So a negative charge of negative 2.0 times 10 to the negative 4th coulombs and a positive charge of 8.0 times 10 to the negative 4th coulombs are separated by 0.3 meters. What is the force between the two charges? So I'm going to look at what I have, and I'm going to go ahead and write everything that I have. So this coulomb, remember that coulombs measures charge, so that's going to be one of the Q's. Okay, and then we have a positive charge, another C, so that's going to be another Q. So I can label this one Q1 and this one Q2. And it's separated by 0.3 meters. Well, 0.3 meters is going to be the distance, and it wants to know the force. Okay, so there's my formula up here, so I'm going to go ahead and plug in all my numbers. So we're looking for the force, and it's an electric force. And then I follow, so we're going to do the K first. 9 times 10 to the 9th. Charge 1 is negative 2.0 times 10 to the negative 4. Charge 2 is 8.0 times 10 to the negative 4. And that's all divided by 0.30. And don't forget, in the formula you square it, so you have to square it down here as well. And then I'm going to get out my trusted calculator and plug all these numbers in. This might be kind of a harder part for some of you, so make sure you're using all the parentheses and that you know how to do scientific notation in your calculator. Okay, so I'm going to do 9 times 10 to the 9th, negative 2 times 10 to the negative 4, and 8 times 10 to the negative 4. I'm just going to do the top part first, and then I'll divide it by the bottom. So on the top, I get a negative 1440, and now I'm going to do 0.30 squared. When I do that, 0.03 squared. So then I come over here and have negative 440. On the top, 9 times 10 to the negative 4 on the bottom. I'm going to divide those two numbers. And that is my answer. The force is negative 16.1234.5 newtons. Whoa, sorry, one hand. Okay, so that is how you would complete a Coulomb's law practice problem.